In this video, we are going to learn about how to create a schematic symbol and PCB footprint for UA741 general purpose operational amplifier. We have completed 10 different tutorials on through-hole technology PCB footprint design activity. That's why this is going to be the 11th tutorial. Hence, I'm considering a SMD IC package design in PCB footprint design. It is going to be very interesting and very different from the through-hole technology that we have done so far. So let's dive deep into that. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. This video is divided into 4 important parts. First one is understanding the datasheet and understanding how to select a SOIC and understand the Cartesian geometry with respect to that. Second step is creating a schematic symbol based on user friendliness as well as aesthetics of the design industry. Third step is all about creating a SMD IC PCB footprint and trying to understand how Cartesian geometry is going to be miniature with respect to SMD ICs. Last but not the least, the fourth step is to combining a footprint that we have designed with the schematic symbol and creating a component library to use it for the future project. So let's dive deep into this project and understand how SMD footprints are designed in PCB tools. Now we are in front of a datasheet of UA741 general purpose operational amplifier. A technical information like electrical properties and a behavior of the IC is given in this datasheet completely in a detailed manner by Texas Instruments. So please make sure that you read this detailed datasheet before designing a circuit using this particular component. But right now, we are focusing on few important parameters which are essential for component library design. First one is schematic symbol representation. Notice we have a non-inverting input and also an inverting input with the output having a bubble in it. I hope you have able to understand this bubble here, which is a very important parameter to design in schematic symbol. That is going to be a new knowledge or a new learning in this tutorial. Then we have a offset N2 and offset N1, which is an external offset for this entire operational amplifier as per the requirement of design engineers. Along with these pins, we have to give a VCC and plus VCC and minus VCC, or maybe a VCC and ground pin based on how you are configuring this particular operational amplifier. So using this schematic symbol for designing a schematic symbol in EasyEDA is going to be very important and very interesting one. Then at the last, we will be having a mechanical detail. In that, we have an option for SOIC and PDIP as well as SO package. But right now, as I said, it is 11th tutorial and we are going to focus on SMD IC footprint design engineering. So that's why I'm going to focus on SOIC. So SOIC is having dimensions which are given here, which is having a 1.75 mm as a max height of the IC, which is very small compared to the PDIP IC. You can consider 1/4 actually, not exactly 1/4, but on an average, it is very small compared to a PDIP IC. And the details of this particular IC, a Cartesian geometry detail of this IC is given in this particular page, which I will try to explain it to you in a simple manner. First thing is the IC pin is having a width of 0.31 to 0.51 mm, which we can consider 0.4 mm for designing the pad on the PCB footprint design engineering. And width of the pad is a choice to us. We can design it however we want based on the entire length of the footprint and all that thing. But the height of the pad is given here. And you can see the very important parameter which is all about pitch of these pins. The pin distance from one pin to another pin is going to be 1.27 mm, which is a standard which we are using from the beginning of this entire tutorial series. And then we have a typical distance from one edge of the pin to the another edge of the pin horizontally, which is all about 5.80 to 6.19. which we can consider a 6 mm for ease of understanding or ease of calculation. And then we have a total height of the body as 4.81 to 5 mm. I'll consider 5 mm for easy drawing the silk layer or the yellow color border of the IC, which is representing the body of the IC. And then width of the IC, height of the IC is going to be this one, and the width of the IC is going to be 3.81 to 3.98. I would like to consider somewhere around 3.7 so that it is easy for us to create a border. But again, it is totally depend on how long width of the pad you are going to consider. Having a height of the pad as 0.312, 0.51. With these details, we are going to start designing the schematic symbol and PCB footprint using EasyEDA. Now I am on EasyEDA and I'll start designing a schematic symbol by going to the File and New option to the symbol. The design activity or a component library design for SMD IC and a through-hole IC is 90% same. Or maybe you can say 95%, but again, 90 to 95% it is absolutely same as we learned in last 10 tutorials. The only difference is in footprint design activity. So that's why I'm going to, straightforward to design this entire component library how we did for the last tutorial. Alright, now you can see that the entire UA741 IC is designed. A schematic symbol is completed. You have noticed that N1 and N2 is looking a little bit weird in this particular symbol, as we know operational amplifiers will be having only 2 input and 1 output, but still as per the data sheet, we have those offset pins to be represented on this particular IC. That's why we are giving them, despite it is not looking so pleasant to us, but at a professional level it is looking good to me because it is usable and we can use them whenever we feel like to give an external offset to the entire IC. N1 and N2 both are given there. Choice is a designer's option where they can create it as per their requirement. One important thing is I'll select the output pin and I'll go and create this dot option here. When we create that dot option, notice how that bubble is created. That is represented on the schematic symbol. So, but if you feel the length of the pin is not sufficient and creating a problem with respect to the out and all the text and whatever you want to change there, you can change the length of the pin by 25 or maybe 30 probably. I think I'll go with a 30. And once we are done with that, I'll bring back the snap size to 10 and the grid size to 10 so that I can adjust this pin as per the requirement of a grid alignment, and just make sure that all the pins are aligned with the grid only. Otherwise, it becomes very difficult to use that particular schematic symbol in schematic design engineering. And I'll go back to the file again just to change the placement of this pin configuration. I'll just change it like this. Maybe I think 25 is sufficient. 30 is going to be too much long. But I'm not sure on that. Let's experiment. These are all experiments actually. We cannot predict them properly. Grid alignment is not possible with a 25 mm, so I'll go with a 30 and I'll just make sure that all the things are placed properly. This is how the schematic symbol for UA741 IC is designed. Notice I have referred the manufacturing detail and supplier detail from the Moser India website, but you can go with the DigiKey, Arrow, whichever source of supplier you are using for your company. Choice is yours, but I recommend to go with Moser or a DigiKey or Arrows, like a genuine website, so that you will get the proper part number, proper supplier part number while you are procuring the component. Now it is time to go for the creating a footprint of SMD IC. For that, we need to go to the file and go to the new one and click on the footprint. The only difference between through-hole component footprint design and SMD footprint design is all about the pads. For through-hole, what we do is we go to the top layer and click on the pad and place them however we want. But here, what we need to do is, after placing the first pad, which is going to be like this one, which is a through-hole pad, select that particular pad, change the layer to the top layer only. Make sure that you change it to the top layer only. Do not design any footprint, especially with respect to SMD IC, on the bottom layer, because bottom layer design is going to flip the entire IC and it is not going to work for assembly work and all, which is absolutely wrong. First of all, that's why you make sure that you are on the top layer, as well as when you click on the top layer, you can see the entire pad looks in a red color. So make sure that you are on the right direction at this point of time. And after that, you select that particular pad once again, or maybe a one which is selected. Change the shape of the pad to the rectangle or maybe oval as per your choice, but I prefer to go with a rectangle, and change the width of the pad to whatever number is suitable for you. For that, I'll go back to the data sheet and go to the mechanical packaging information. And if I scroll a little bit down, when we find that SOIC, we have a height of the pad is going to be 0.31 to 0.51. I would like to go with a 0.4 probably at this point of time, which is average of both the numbers. So a height of the pad is going to be 0.4 and width of the pad is going to be, I think I'd like to go with what size? If we find a little bit detailed way, we will get that information in this particular data sheet only. Here it is. I think I got it actually. You can see what is the length or what is the width of that particular pad which is bending and landing on the PCB. That particular land, which is so-called foot of the IC, that's why it is so-called footprint. So that particular foot is having a width of how much? 0.4 mm to 1.27. Oh, it's very long actually. We can choose to go with whatever size we want. So I think let me find, okay. We have a very important information here. That information is the land pattern. This is the recommended land pattern from the Texas Instrument. I forgot to see it while we are studying the data sheet. So now I discovered it. So that's why I make sure that you read the entire data sheet before starting with creating any footprint. So here we can see that the land pattern is given with a very detailed information which is recommended from the manufacturer. height of the IC pad is going to be 0.6 mm according to the manufacturer. So I'll refer and go ahead with that 0.6 mm. And width of the pad is going to be a 1.55 mm, which is recommended from the manufacturer again. So I'll go with a 1.55 mm. Once we are done with placing this particular pad and changing it to SMD pad as per this one, then I'll go and click on the pad again, or you can use the P key on your keyboard and just place the all pads as per the design standard as we used to do for through-hole component. And this is going to be only the difference between a through-hole technology component design and a SMD technology component design. Here and after, it is going to be the same as how we used to do for the through-hole. So let's do it together. Alright, now you can see that the small outline integrated circuit SOIC 8-pin IC footprint is designed. It is absolutely same, but the number of pins, or maybe the placement of the pin, or the distance between the pins is going to be in very small minute dimension. For example, we remembered 2.54 mm is the pitch of the IC or pitch of the pin in case of through-hole technology. Now it is going to be 1.27 mm, especially with respect to SOIC package, which is half of the size of the PDIP IC. That's why they are so called a miniature components in circuits. So that's why when we get into the dimension of the pitch of this SOIC, we need to know that the dimension of one pin to another pin, which is a pitch of the IC, is 1.27. We need to divide that 1.27 by 2 once again to get to know that 0.635 is the distance from 0th position of x-axis to the y side of the y-axis, which is all about 0.635. I think 0.635 from the x-axis origin of y direction, from that positive side as well as from that negative side. That's why the coordinates or the Cartesian geometry for this particular pad is going to be 0.635 on y-axis, as well as in x-axis it is going to be 2.7 mm. Why 2.7 mm? Based on the land pattern, you can see that the total distance or the pitch from vertically these group of pins to these group of pins is going to be 5.4 mm. And if you divide a 5.4 mm divided by 2 is going to be 2.7. That's why I have considered 2.7 for all of these pins and minus 2.7 mm for all of these pins on x direction. Y direction, it is computable as we did and as we discussed right now. Once we are done with the saving of this particular footprint, which is SMD footprint, now it is time to combine this footprint with the schematic symbol that we have recently designed. For that activity, what we need to do is we need to go to the schematic symbol that we have designed and click on footprint activity. And there I'll search for SOIC_08. Giving a proper name for all the footprint or a schematic symbol that we are going to design is going to help you a lot in the long run. So practice a proper and professional naming or nomenclature for all the components that we are going to design. So once I'm done with that, I'll click on it. Long back in our previous company UTD, we used to design these footprints. That's why you can see one particular package is visible to us. But we'll ignore that at this point of time. But once we click on the package or the footprint that we have designed right now, you can see that one pin is not associated with any of the pins, and that is indicated here. You can see only 7 pins are here, and 8th pin is not associated anywhere. This one is NC as per the data sheet. You can see here in the feature section or in the pin details, actually pin configuration, the 8th pin is NC. Now you need not to do anything for that particular thing if you are very much aware that particular pin need to be left open. If you want to consider that pin in the design activity, then you can give one pin extra and name it as NC and also give a part number or pin number as a 8th pin. Choice is yours, but at this point of time, I'm going to ignore that and click on update. Once you're done with that, your entire schematic symbol and the PCB footprints are combined together. Now you are ready with the component library for UA741 general purpose operational amplifier. Super duper! I believe you have learned and enjoyed the process of understanding and creating a SMD IC PCB footprint in this tutorial. If you have any questions or suggestions or any discussions, feel free to comment down below in this video. I'm going to answer your questions as and when possible for me. Thank you so much for watching this video. Share this video with someone who may need these kind of tutorials and help us to grow in YouTube community. See you again in the next video. Until then, tune yourself to make a difference.